Arbitrary terrain generation. Terrain is likely to be the main object of your outdoor worlds. It defines environment, and therefore the impression your project makes. Unigine Editor offers you the Landscape tool to create terrains, be it an arbitrary landscape for a game, or a geo-referenced one to reconstruct an exact location for simulators. An arbitrary or synthetic terrain representing a certain landscape is generated using only ordinary raster images, with no geodata. If you want to learn how to create a geo-referenced terrain, please follow this link to watch the dedicated tutorial. In this tutorial, you will learn the basics of arbitrary terrain generation and learn how to make it look more natural by adding details, creating vegetation, and use some other features. To create a terrain, let's open the Landscape tool by choosing Tools, Landscape in the main menu of the Unigine Editor. If you have a Sim SDK edition to create a synthetic terrain, you should set mode to flat. Other SDK editions support only the flat mode, so it is set by default. The interface of the Landscape tool includes the Preview panel, containing the rectangular play area showing the actual area of your terrain. There are also the Settings panel, the Parameters panel. It works the same way as the Parameters window of the Unigine Editor, the Generation button, and the Sources panel, where you should specify the data sources for your terrain. Height, elevation, albedo, imagery, and masks, land cover, that are used for vegetation. Procedural data refinement using Houdini digital assets is also supported. It can be used to improve the quality of generated terrain and will be covered in our advanced level series of tutorials. The data for a terrain can be created using World Machine or other terrain generation tools as well as any raster graphics editor, Photoshop or other. The most widespread formats are supported. Please note that the quality of generated terrain is determined by its size and the quality of the data sources used. However, you can easily create high-resolution insets by adding a high-detailed landscape layer over a low-detailed one. This can be useful for flight simulators, where high details are required only for areas around airports. To specify the height data, click Add Source and make sure you've set the layer parameter to height. Then specify the name for the layer and the path to files containing height maps. Note that indexed black and white files cannot be used as elevation data sources, as they are interpreted as RGB images. Then click OK and wait for the data to load. You can now see the data source in the Preview panel. Scroll the mouse wheel to scale the view. Data beyond the borders of the play area will be ignored, so adjust the locations and sizes of the data sources the way you need by dragging the corresponding rectangles or their control points. Right-click and choose Focus to Play Area option to show current play area. We check the play area size via the Parameters panel after selecting the corresponding settings section. It is covering an area 3 by 3 kilometers now. You can also do it precisely via the Parameters panel. Select the layer and set the size of the largest side of the data source in kilometers, or its density in meters per pixel. Let's set its largest size equal to 3 kilometers. We can also set the position of the data source center. Let it be the origin. Height layers also have elevation settings. You can use elevation scale parameter to adjust terrain heights if they're in float format. Otherwise, you can normalize them by enabling the corresponding option and setting minimum and maximum limits in meters. Let the upper limit be equal to 1 kilometer. Perform the same steps for albedo data. The data source can be represented as a single raster image or as a set of images, source tile set. In this case, you can only specify the first file of the tile set. Other files will be added from the same folder automatically according to the naming type and expression value. For example, having set the naming type to row column, you can use the expression parameter to detect the remaining parts with the X and Y coordinates in their names. You can leave the default expression pattern or change it to fit your needs. In the Preview field, you'll see the number of files selected according to the specified parameters. Other naming type, index number, enables you to load an index sequence of images as a tile set based on the specified number of columns. Having specified all the parameters, click OK and wait for the data to load. In addition to area and position settings, albedo layers have the No Data Color parameter that provides the color for areas with no data provided. You can manage the levels of detail for height, albedo, and mask data sources via the Parameters panel when the corresponding group is selected. Visibility distances and densities are generated automatically, but you can adjust them to fit your project requirements when manual mode is selected. By default, the data source's processing order is determined by their density from high to low, but you can change ordering if necessary via the Processing Priority section. You can also speed up generation process using the power of your computer network by adjusting settings of the Distributed Computing section. Before we start generation process, we should specify the output directory location for our terrain, as well as the location to store generation cache. These settings are available via the Output File Location section. Let's create a landscape folder to store our terrain. Then we should specify the location for data cache, for example, on your local or shared storage if you use distributed computing. It is recommended to put cache files on an SSD storage device for best generation performance. All generation settings that you make for your terrain can be saved to a landscape asset to be loaded and used later. You can do that via the File menu. Having set all the parameters, you can generate the terrain by clicking Generate. In the Generation Steps window that appears, you can select what is to be generated without rebuilding the terrain itself. Let's generate the terrain using elevation and imagery data first. Enabling the Imagery Previews option will show previews for generated terrain on the world map. Click OK to start generation. Note the generation process may take a lot of time depending on the play area size and density of the data sources used. Upon completion of the generation process, you will be offered to optimize world settings for your terrain. We choose Apply. A new global terrain has just been created. It has the size of 3 by 3 kilometers in the virtual world. In addition to it, the landscape camera has been added and placed at the center of the terrain with all necessary parameters adjusted automatically. A set of auto-generated beacons can be used to quickly navigate across the terrain. On the Parameters tab for the landscape object, you'll find LOD settings for all terrain layers. It's important to accurately set their visibility distances while avoiding having too dense grid in the areas far away from the camera. At the moment, our terrain looks a bit flat, as a single albedo texture is not enough for a closer look. We can improve terrain's visual appearance by adding details to it. For this purpose, we will create masks. We should add some land cover data sources first. We choose the albedo texture. We again adjust area size for the data source to fit our play area, and then add tags for vegetation and rocks. Tags represent a color range or a texture channel and are used to filter the data necessary for generation of certain land cover areas. For each tag, we can specify a set of attribute filters to select certain data from the land cover data source. Several filters are used together with OR binary operation. For example, we can spread grass both over the areas having white and green color on the map. You can use albedo color for masking, which makes it easy to filter vegetation area. We just need to pick a color from the terrain surface and click the plus button to add a filter. The same way we specify an area for boulders and rocks, we can use threshold to expand filters and cover adjacent color shades. The last step is to select all tags that we plan to use as masks for our terrain in the Masks section, and click Generate. This time, we only need details. So we can see masks created in the LOD section of the terrain parameters, and we're going to add some details. Click the plus button to add a new detail. By default, it is painted white and covers all the terrain. Select the mask to be used for the detail. Here we can adjust threshold, width, and contrast to fit our needs. Areas for details can be specified either by selecting a mask from the ones generated or simply using the albedo color of the imagery layer via the Mask by Albedo option. In the Textures section, you can specify desired textures for detail. As you're done with that, click Update Arrays to see the result. Don't forget to do it after making any changes to textures. Let's fix tiling in the corresponding section by increasing the size parameter. Change the blending mode to overlap to substitute underlying layers. You can also use additional parameters of each detail texture for fine-tuning. We can set visibility distances for each detail to provide best balance between look and performance. It is recommended to configure distances so that fine details are displayed only at close distances, as they're unnecessary when they're far away. You can add as many details as you need, as well as manage their hierarchy. The subdetail flag indicates that the detail will use the mask of its parent. Let's apply the same textures to the subdetail level, but change tiling a little bit for close distances. So, we improved the look of our terrain by adding just a couple of detail levels. Then we add new detail layers to improve the look of rocks the same way. You can enable triplanar mode for detail textures. By default, planar UV mapping is used. That's why the textures get stretched on steep faces. To get rid of such artifacts, just enable the triplanar option. Now let's add some vegetation to our terrain. Let's start with grass. Let's create a new grass object. Assign a material to it and adjust it. We'll need to enable some states: noise, ambient occlusion, translucency, and MIP bias. Assign corresponding textures. Add a mask texture and increase the density. After simple adjustments, we've got a nice grass on the ground. Let's create a node reference from it by dragging the node to the Asset Browser window. In the Vegetation section, we can add a basic object for generation by clicking Add button and specifying object's name. This one is for grass. For our basic object, we specify the tag to be used for object placement on the terrain and the path to the corresponding node file that will actually be used to represent our object. We use the grass mode. To generate vegetation, we should check the Land Cover Objects option. Well, we have added grass to our terrain, and it's scattered across the area specified by the tag that we used. We can add a forest to the landscape using array of meshes called mesh clutter. When creating one, you should specify a mesh to be reproduced. In our case, it's a tree, and we'll take it from an FBX asset. As the model contains several LODs, we need to set up their visibility distances and assign corresponding materials for leaves and trunk. In the parameters of the mesh clutter, we adjust its size, density, and random seed. And we're also going to convert it to a node reference asset. We can add as many objects as necessary, so let's diversify our vegetation by adding a mesh clutter for another type of tree, spruce. All we need to do now is to create basic objects for clutters and specify tags and node files for them. Again, we'll generate only land cover objects. Well, the objects for forest and grass has been created using the nodes that we specified. This greatly improves the terrain look, but only at a close distance, which corresponds to visibility distance of the nodes that we used. Increasing maximum visibility distance will show more trees, but this will significantly affect performance. That's why we suggest using levels of detail and mixing real geometry represented by mesh clutters, with imposter objects imitating geometry with a set of sprites. We can use Imposter's Creator to create imposters for a clutter object automatically while keeping positions, sizes, and appearance of meshes. Click Create and specify the path for our imposters. A new Pine Clutter Imposter object has been created and added as a child to the clutter. Now the huge number of trees is visible while performance is kept high. It is recommended to increase the minimum visibility distance to make imposters appear only behind the least detailed LODs of tree meshes. Let's set it to 150. So again, we make a node asset and perform the same steps for spruce imposters. Now we should add additional vegetation objects for our imposters, choosing the same tags as we did for geometry trees. And after regeneration, we see that our terrain looks much better without hitting performance. As the camera moves, geometry trees are smoothly substituted by imposters. You can edit any height, albedo, or mask LOD of the global terrain object using the Terrain Editor tool. To start editing the terrain, click the Edit button at the top of the Terrain Global tab of the Parameters window. To edit detail masks with a brush, open the Terrain Editor in the Mask Edit mode. Choose the desired mask and level of detail, specify the intensity, and draw with the Alt key and left mouse button. Use the Alt plus right mouse button to pick the color at the certain terrain point, and mouse wheel to change the brush size quickly. Don't forget to click Apply when all adjustments are made. We can also adjust terrain heights manually by selecting the Height Edit mode. Use Height parameter to control positions of points under the brush. It's a convenient way of creating hills and canyons manually. If you want to add some smoothness, Select the Smooth mode and move the brush over the areas you want to remove sharp edges. You may have noticed that trees do not follow the terrain surface as we modify it. To provide correct alignment, we should regenerate land cover objects after making all modifications. Remember that all your changes made to elevation, imagery, or masks will be discarded if you choose to regenerate these data layers. That's why we select land cover objects only. After regeneration, all grass and trees are placed exactly where they should be. Unigine provides some techniques for terrain surface modification. As an example, let's make a tunnel through a hill. To cut an area of terrain surface out, place a decal object opposite the tunnel's entrance. You should assign the decal terrain hole base material to our decal to use it for making holes. Then we assign a special texture, which corresponds to the tunnel's form. And here goes the magic. We've just made a tunnel through the terrain surface. Don't forget to do the same for the other end. The only thing to be fixed now is grass and trees overlapping the tunnel entrance. As they are generated according to the vegetation area tag, we can exclude this spot from the mask using the Terrain Editor tool. Set the intensity to 0 and erase the vegetation area mask over this place. Then, regenerate the land cover objects in the Landscape tool to remove unnecessary vegetation from the entrance. You can use the Terrain Lerp option of the mesh-based material to mark objects to be covered by the projected textures of the terrain global object. It is an easy way to improve the landscape by integrating complex meshes into it and thus creating more detailed areas than the global terrain is able to provide due to limited density. Voila! And the tunnel becomes a part of the terrain in a single click. Remember that a landscape in your scene with all its features is a very complex element that significantly affects performance and requires optimizations to fit your project's requirements. For more information, please refer to our online documentation.